Hello, so this is a revision video for IB Chemistry S1.1.3, Temperature, Kinetic Energy, and Changes of State. This is a revision video, so only the essential information is given. For more detailed explanations and for full video lessons, please check the links in the description below and visit chemistrystudent.com. Temperature tells us about the average kinetic energy of particles in a substance. The hotter something feels, the faster the particles in it are moving. And the colder something feels, the slower the particles in it are moving. As a result, kinetic energy increases as the temperature of a substance increases. Because of this, if particles have no kinetic energy, they have no movement. The temperature at which this happens is referred to as absolute zero, and is measured in Kelvin, absolute zero being 0 Kelvin. At this point, there is no particle motion, and it is the theoretical lowest temperature possible. The Kelvin temperature scale is needed because 0 degrees Celsius doesn't correspond to 0 amounts of energy, which makes calculations really rather difficult. 0 Kelvin is the same temperature as minus 273 degrees Celsius. So the Kelvin temperature scale starts at minus 273 degrees Celsius. A change in 1 Kelvin is the same as a change in 1 degree Celsius. So when we go from 0 to 1 Kelvin, we go from minus 273 degrees Celsius to minus 272 degrees Celsius. But be careful, just because a change in 1 Kelvin is the same as a change in 1 degree Celsius, 1 Kelvin isn't the same as 1 degree Celsius. So to convert between degrees Celsius to Kelvin then, we have to add 273. To convert between Kelvin to degrees Celsius, we subtract 273. When a substance is changing state, for example during melting or boiling, the temperature of the substance stays the same, even though energy is usually being added or removed. This is because the added energy is being used to break intermolecular forces, rather than speed up the particles in the substance. We can show this when we plot something called a heating curve, where we measure the temperature over time while we heat up a solid. For example, the heating curve for solid ice shows that the temperature of the solid ice increases while heat is being applied, before then plateauing while the solid melts into liquid. Then, once all the solid has melted into a liquid, the temperature increases again before it then plateaus during boiling before it all becomes a gas. The flat parts of the graph show the changes of state. Energy is still going into the system, but it isn't raising the temperature because that energy is being used to break the bonds and forces holding the particles together, instead of making them move faster. Once those bonds have been broken, then the added energy can be used to make the particles move faster again, which is why the temperature starts to increase after the change of state.